One of the biggest problems with event-driven architecture is what happens when something breaks. What happens when a consumer starts to get 2,000 or 3,000 or even 4 hours behind?
Post is viral, the volumes of data is high. What are the implications? Where my brain is going, as you were going there, my wheels were spinning. At that point, my part is done. This is going to be an interesting... Any horror stories that you are familiar with?
Oh, yes, absolutely.
Hello, and welcome to Coding Culture, the podcast all about technology, innovation, and everything in between. I am your host, Kgang. If you cannot pronounce it, you can call me Kgang. Today, we are diving into a very interesting topic where we'll be talking about event-driven development. To the couples, don't worry. When I'm talking about concepts like decoupling, loose coupling, I'm not suggesting that anybody break up, but we'll also be dealing with topics like resilience that should probably maybe keep you guys together there. But my guest will tell us further about this topic here. I'd like to welcome Jonathan.
Hi, and thank you very much for having me. It's good to be here.
Good to have you. So when we're talking about event-driven, what I want to know is that let's maybe build the building blocks a little bit. Let's start with the first block. Why event-driven?
Okay, so to understand event-driven, you have to take a step back. Take a look at what we currently have in your standard paradigm, your synchronous transactions. You have your event that happens, and it goes and it asks for the next state to occur, and then that system asks for the next state to occur, and everything rolls back. Event-driven takes a completely different approach. It is asynchronous, very much aligned with the idea of fire and forget, where your front end goes to the back end and says, here's a message. That system then takes it to the next system and says, here's the next message. And things get passed from system to system as events where you don't necessarily wait for the response. And that is, in essence, what event-driven systems do. You have a event or a message that passes from system to system to system.
Okay. So let's say the systems are a relationship. I just want to see if I'm getting you. Because it sounded like now if we're in a relationship here and I say something to you, I'm like, hey, Jonathan, I'm leaving. At that point, my part is done. How you receive the message and whatever, I'm not involved at that point. Am I grasping it correctly?
In essence, yes, because your traditional systems have synchronous, you send a message, you wait for the response. In event-driven, an event happens, a state changes of an object, and that state now gets carried forward to the next system. The original system would then be listening for another event to tell it, okay, this is your final result, go and deal with it. So it's not waiting, it's not synchronous. It is completely decoupled. But it is an asynchronous way of handling with state changes.
Okay, I knew that word would come eventually. So I think let's try to piece it together there. Let's say we've got some key players here. I heard something about events or messaging.
So your key player would be your broker. Your broker handles the routing of messages. Then you have your consumer, which listens for a message or a event that changes state. Okay. And you have your producer. Now, your producer would be the item that actually produces the message. So when you want a state to change, when a user clicks buy or deposit or withdraw or bet, for instance, anything that a user does would be considered an action. That action would trigger a state of change. That state of change is a message that gets sent via a producer to a broker. From that broker, it is then distributed amongst the consumers. I don't know if I got it broken down simply enough.
No, I think I get the concept there. So with what you've mentioned now, I think the key thing that just if you zoom out is like I want to click something and I want to know that the thing happened and I want quick response. How does this deliver that promise?
So what the event-driven systems allow you to do is, because it's asynchronous, you can click deposit, let's say. That will take you to a place where you can now start filling out a whole bunch of details and fill out all the other details that you want to do for a deposit. However, in the background, that click on the deposit button could have started preparing communications to other systems. The moment you click on your bank to select where's the deposit coming from, it can say, okay, prep this consumer. It can pre-warm up the entire system so that it knows where it's going to be routing this message to. You then click deposit and your little wheel on the front end starts spinning. That little wheel is waiting for a message to come back. However, it is not holding up any other transactions from any other people. Whereas in a synchronous system, your legacy systems, for instance, that are not asynchronous, they are tying up that CPU and waiting for it. So your event-driven systems very much help you improve your scalability of your system. So you're not trying to process things in sequence. You are sending them off and waiting for the reply.
Okay, sounds good. I think I've got that. Send the message, we wait for the reply. I think where my brain is going, as you were going there, my wheels were spinning now, where I'm thinking, okay, there's a lot of different players in this relationship here. Now, when I think resilience, if one player is down, does the whole thing crumble?
Yes. Errors, concurrency, and states of change. One of the biggest problems with event-driven architecture is what happens when something breaks. What happens when a consumer starts to get 2,000 or 3,000 or even 4 hours behind? Your initial state change can trigger off multiple consumers that each do multiple different things in their chain of events. Now, you have one message. Let's say this message would be update a phone number. That would go, it would update your phone number, and that would be done. That would then trigger off a new message to verify that the phone number is legitimate. However, your SMS sender is offline. Okay. That means that the person didn't get their PIN to verify that their new cell phone number is in fact their cell phone number. You have two choices. All right. Either you can wait and give that person as much time as they need to get that, or you can trigger off a failed state for that. And deal with it when that consumer catches up. So you have your retry mechanism, which you can have. So you can retry the same message twice, or you can go down the other path and architect an override so that it rolls it back. Yeah, so event-driven systems failure, you have to be very careful about how you architect your system and how you design it. uh, because it is not concurrent all the time. It relies on eventual concurrency.
That's very interesting. Let's say now I'm on social media. There's like I make a post. The post just goes crazy. It's viral. Every 3 seconds there's a reply now. Like if you were to just run me down now with the system and event driven, how does this come together now? The post is viral, the volumes of data is high. What are the implications of this?
Okay, so let's assume your final backend layer is MongoDB, where you are storing all the replies to your post in a document store. Right. We know for a fact that MongoDB is nice and fast on inserts on condition that they're all short and sweet. Okay, cool. Now we are limited to the absolute maximum of inserts and reads that we can do from MongoDB. Your post has gone viral, and let's say we've got fantastic caching systems for the reads, so we're not reading directly from Mongo, so we're not bottlenecked there. However, we want to get as many posts in there as possible, and we are far exceeding our capability on Mongo. Your event-driven systems would say, okay, your producer would put in a message to a topic or a queue. This would be dependent on whether you're using Apache Kafka or RabbitMQ or Amazon SNS or even Azure's message system that they've got.
Yeah.
All of these systems function very similar. And that would sit in your topic or your queue, and your consumers that actually write to Mongo would then go and sequentially add the messages as fast as Mongo can keep up, which would allow your caching layer to read from MongoDB every couple of seconds instead of as a new one comes in. And you would get all your posts, all your replies, all your comments eventually. You won't get them the moment they're there. So somebody could make a post and it could take 3, 4, 5 seconds to show up, or 4 or 5 minutes, but it will be there eventually.
That's very interesting. So, as developers, we love patterns, and I'm not referring to patterns on clothing. It's like when thinking about this paradigm here, are there any common patterns that people can use?
There are a lot of patterns that work well and a lot of patterns that don't work well. However, it is completely situational. For instance, when dealing with databases, one of the most common things people say when dealing with a database is avoid heap tables. However, there are very certain circumstances where those are necessary, not just a good choice. The thing you need to remember with event-driven systems is they are very complex, and you need to be careful with concurrency and how you deal with your concurrency and how you deal with errors. So as long as the design pattern that you're using is able to anticipate or deal with an error state, it's going to be fine.
Okay. This is going to be an interesting one. Any horror stories that you're familiar with?
Oh, yes, absolutely. Many, many years ago, we're talking 7 or 8 years ago, I was with a team. We were migrating from RabbitMQ to Apache Kafka because we thought, okay, the bottleneck was with the messaging system.
Blame the system. Yeah.
We were wrong. The way that the messages were being handled and merged in the database layer after that is where they were all falling apart. And we basically spent, I think it was around about $10,000 switching from RabbitMQ to Kafka, only to find out that the actual messaging system wasn't the bottleneck. Yes, it did speed things up, but nowhere near as much as we were anticipating. And the implementation costs of Kafka were significantly higher than the little RabbitMQ system that was running things fine. So when it comes to your queuing systems, make sure that you use the right one for the job.
Okay. My favorite genre is horror, so thanks there for that horror story there. So we discussed the patterns a little bit. I want to get into the tooling maybe, like you've been mentioning it as we go there. I think I heard something about Rabbit, about Kafka.
So two of your most common and easy to get familiar with ones would be Apache Kafka, which can be very easily spun up in Docker containers. So you can set it up on your local dev machine with a few keystrokes. The entire thing is written in Java, I believe, as the base, with a little bit of C++ for their tooling. And it's very straightforward, very easy to get used to. The nice thing with Apache Kafka is each queue or topic, as it's referred to in Kafka, can be sharded.
Okay.
When I say sharded, I mean you've got partitions inside of the topic, which allows you to set how many consumers you have from there. In a fully fledged system, like the paid version Confluent, it can have immense throughput, and it is beautifully powerful. If you're going to be working on something that doesn't need 15 consumers to be run, going for millions of messages a second, something along the lines of RabbitMQ is often going to be your more cost-effective route. It is just as powerful, just as supported in multiple languages, and a lot of people find it easier to use.
Okay. Thanks for that. I think I learned a lot here today. I think the audience has clearly also learned a lot. Talked some pattern, made some couples break up, got decoupling in there. In conclusion, like it sounds like for scale and eventual consistency, I think we understand your tools, understand your patterns, and this could be an interesting paradigm to solving your problems. Thank you very much there, I think, for the conversation that we've had here. I really enjoyed it. My inner gig was just excited with the conversation there. And thank you for your time today.
Absolute pleasure. Thank you very much for having me.
Thank you, Jonathan. This is Coding Culture, the podcast that is all about technology, innovation, trends, and everything in between. I am your host, Kgang, aka Kgang. As we mentioned earlier, we've got some competitions that are running where we would want you to answer some stuff in the comments there. So as I was chatting to Jonathan, something came up to mind here. The question that I want to ask where you can win a prize is this. It's got nothing to do with couples, remember, but what is decoupling? I will repeat this again for you. What is decoupling? Make sure to answer in the comments. And also, please do make sure to look for the link below to join our mailing list. Share the podcast, comment. Let's all collaborate. Let's talk about this. Stay coding, stay innovative. Coding culture. Out.